Welcome back to this class. So in this class, we are going to start implicit functions, that is derivative of implicit functions. So how do we differentiate implicit functions? So the first thing is that what is implicit function? So all the techniques of derivatives that we've been dealing with right from the beginning of this class will only be dealing with explicit function. That is, if y is explicitly a function of x. This is an explicitly function. So you have y equals to x plus 2. So in this case, we call this y dependent variable. So dependent variable. So we call this x the independent variable. The independent variable. So independent variable. So the meaning of this is that y depends on x. So whatever the value of x is, that will determine the value of y. So if x is 1, so that means if x is 1, that means y will be equal to what? 1 plus 2. And that is equal to what? 3. So that's what we call y dependent variable and x the independent variable. So in this case, you can see y is on one side and it's expressed as a function of x. So but in the case of implicit function, so it's a case whereby y is not explicit. So it's a case whereby you have something like x squared plus y squared equals to 4. So look at the function that we have here now. Y is not expressed as a function of x, that is in explicit form. So in this case, it is an implicit function. So how do you differentiate y in this case? If you're very good with algebra, so you might think then we'll just make y the subject of formula. Well, that's good. So, but it's not always easy. There are some functions that you have that you can't express y as an explicit function of x. So in that case, you have to apply the technique of derivative of implicit functions. So, and that is what we're going to do in this particular class. An example. So example, let's write an example. If y is equals to, let's say, x squared plus 4, this is an explicit function. Explicit function, explicit. Sincerely, this thing is not easy to pronounce. Explicit. So if we have x squared plus y squared equals to, let's say 4. So in this case now, this function is what? Implicit function. So y is an implicit function in this case. So because y is not expressed explicitly as a function of what? X. So you can see how we differentiate this is different from this. So how do you differentiate this kind of function? So an example, we'll use this as an example 1. So example 1. So if y, find the derivative, find the y dx if x squared plus y squared equals what? 4. So you find the y dx. So how do you differentiate this kind of function? X squared plus y squared equals 4. Then to find the y dx, so differentiate x squared with respect to x. That means I want to find d dx of x squared plus d dx of y squared equals to d dx of what? 4. So I going to differentiate all of this with respect to x. Now, the derivative of x squared with respect to x is going to be what? 2x plus, now, derivative of y squared with respect to x. Now that's where we have to apply this. Now, y squared is a function of another function. Y squared is a function of y, and also y also is a function of what? X. So that means from here, if you apply this, if y is equal to f of u and u is equal to f g of x, another function of x, so then the y dx will be equal to the y du times the u dx. So then from now, y squared is a function of y. So that is, if y squared is a function of what? Y, and y is a function of what? X. You get that? Y squared is a function of y, and y is a function of x. Let me write that here. Come here. So from our function of function, what we have is that if y is equal to function of u and u is equal to function of x, then we used to say that the y dx, you want to differentiate y with respect to x, will be because first you differentiate y with respect to u, the y du times, then you differentiate u with respect to x, du dx. Now we have it that y squared is a function of y, you get that, and y itself is a function of x. So now to find the derivative of y squared with respect to x, that is derivative of y squared with respect to x, will now be equal to, you differentiate y squared with respect to y, that is the y squared dy times what? Times the y dx. So just like we have here, when y is a function of u and u is a function of x, then the y dx will be equal to the y du times du dx. So here, y squared is a function of y, and also y is a function of x. So in this case, we have that the y squared, the derivative of this function with respect to x will now be equal to the y squared dy, at least you differentiate y squared, just the way you differentiate y with respect to u here. So here you differentiate y squared with respect to y times y with respect to x. You now multiply both together. You get that? So for me now, d dx of y squared, d dx of y squared, so will be equal to, so dy squared dy times dy dx. So equals to d dx of 4. The derivative of constant with respect to x is what? 0. So from here now you have 2x plus, so differentiate y squared with respect to y, which is with respect to y. Y squared with respect to y, that will be equal to 2y times dy dx equals to what? 0. So the next thing now is that you make the y dx subject of the formula. So from what we have here now, 2y dy dx will be equal to 0 minus 2x. You got it? 0 minus 2x. So, and from here now, you have that 2y dy dx will be equal to 0 minus 2x, that's what? Minus 2x. So from here now, you have divide both sides by 2y. So you have the y dx will be equal to minus 2x over 2y. So from there now, 2 cancel 2. So that means you have dx will be equal to what? Minus x over y. So that is the y dx will be equal to minus x over y. So I hope you got that. So that is the derivative of x squared plus y squared is equal to minus x over y. Another example, so example 2. So I intentionally left this so that you can see we are going to make use of it here again. So we have 2x squared plus xy equals 10. So then we want to find the derivative of this. So find the y dx. So we want to find the y dx from this. So from what we have here now, that means we want to find d dx of 2x squared plus d dx of xy equals to d dx of what? 10. So first, you differentiate this with respect to x. So the derivative of 2x squared with respect to x, 2 times 2, that's what? 4x raised to the power 2 minus 1, which is 1, plus. So you're going to differentiate this with respect to x. From what you have here now, this is the product of two functions. Two functions. X is a function, y is a function. So that means you differentiate this as a product rule with product rule. First, you pick the first one, x, then you differentiate the second one, the y dx plus y dx. So the x dx, that is differentiate x, which is what? 1. So equals to d dx of 10. The derivative of 10 is equal to what? 0. So then from what you have here now, we have 4x plus, so we have 4x plus x dy dx equal plus y equals to 0. So then from here, we'll make the y dx subject of formula. So from what we have here now, that means x dy dx will be equals to 0 minus, you bring this 4x here, minus 4x minus y. So that means, so from what you have there, you have that to be now x dy dx will be equals to minus 4x minus y. So then from what you have here now, to find dy dx, you divide both sides by x. So then you have dy dx will be equals to minus 4x minus y all over x. So that is the derivative of that, minus 4x minus y all over x. So let's solve one more example. Example, we have x squared plus y squared plus sine y equals 11. So we want to find the y dx. So from what we have here, that means solution to this. So that means you want to differentiate d dx of x squared plus d dx of y squared plus d dx, that is, you differentiate all these of sine y equals to d dx of what? 11. So that means we differentiate all that with respect to x. So from what we have here now, differentiate x squared with respect to x. And that's what? 2x plus differentiate y squared with respect to x. So you remember what I told you the other time is that y squared is a function of y, and also y itself is a function of x. That means function of another function. First, you differentiate y squared with respect to y, and that will be equals to 2y times, you now differentiate y again. The derivative of y is what? Dy dx plus. So here we have sine y. So sine y, if you want to differentiate it with respect to x, first, sine is a function of what? Sine y is a function of what? Y. And y is a function of x on its own. Do you get that? So sine y is a function of y, and y is a function of what? X. So if you want to differentiate this with respect to x, that means derivative of sine y with respect to x now, because you differentiate sine y with respect to y, d of sine y dy times you differentiate y with respect to x, dy dx. So you get that. So to differentiate sine y, so first you differentiate sine y with respect to y, d of sine y dy times, you differentiate y, dy dx. So equals to, so differentiate 11 with respect to x. The derivative of any constant is what? 0. So from what we have here, you have 2x plus 2y dy dx plus differentiate sine y with respect to y. That will be cos what? Cos y dy dx. So you have this equals what? 0. So from here now, we'll make dy dx subject of the formula. So that means we have to collect the like term. You have 2y dy dx, cos y dy dx. So that means all those two of them are going to be on the left hand side. 2y dy dx plus cos y dy dx equals to, now bring 2x to the right hand side. That will be equals to 0 minus 2x, right? So from what you have there now, from here now you can factorize dy dx. Then you have dy 2y plus cos y equals to minus 2x. Dy dx will be equals to minus 2x all over 2y plus cos y. So minus 2x all over 2y plus cos y. So that is dy dx. So that's where we're going to stop in this class. So I'll see you in the next class.